Hello, everyone, and welcome to online lecture 12. This will be day 2 of inferential statistics and hypothesis testing. So the good news about today is that there's really just one main idea that I'm trying to communicate to you, and I'm going to try to do it through some different tactics. So if you don't like one tactic, you might like another one. Okay, so let's jump right in. So we've been talking about hypothesis testing a little bit, and we've been talking about this notion of how we're going to make this decision as to whether our group or our variable is significant, right? And we've been talking about if our group is significantly different from the population. So here's our population of folks who never took vitamin, okay? And this is their energy levels that we're looking at here, okay? So this is along the middle here is their mean energy level, and this is their distribution of energy levels. Now we took a little sample, which I'll show you with a little blue trapezoid. We took a little sample of people and gave them vitamin, if you remember. This is our vitamin group. And we can look at its distribution. Now, it's not quite normal because it's only just a little sample, but we can see if we look at the mean score by, again, looking at the center of the distribution, the mean score for vitamin is, wow, it's really up here. It's really up by like, beyond 130, whereas the mean here is around 100. So if we are looking at a standard deviation of 15, then we would be well beyond 2 standard deviations above. Okay, so that's pretty interesting. And we might say that, okay, I'm going to take my guess, and it is a guess, and I'm going to say that this group of people who took vitamin had significantly higher energy levels than the population at large who does not take vitamin. Great. Now, the question is, am I right or wrong? The answer is, in general, I don't know. Because I don't know what the whole population looks like. You see, the population could look like this, perfectly lined up with my sample. Looks like my sample was quite representative. And then I made a correct decision, and I should have rejected the null. I should have said this is significant. However, I'm going to skip ahead for 1 second because I think this will maybe make it a little bit easier. However, let's say that my population actually looked like this. This is the same setup, except the only thing that's different is that in reality, my population did not match up with my sample. My sample was biased. It was non-representative of my population at large. See, then I went ahead and rejected the null, but I shouldn't have. So in both cases, in A and in C, I rejected the null. I made a very reasonable decision to reject the null based on my sample, comparing it to the population without vitamin. In one case, I made a correct decision in the first case. In this case, I'm making an incorrect decision. Okay. Now let's look at something else. Let's go back. Okay. Let's go right here. Okay. So now let's look at our population once again with no vitamin. And let's look at the folks who actually took vitamin. Now in this case, I have my little sample here. Again, my blue trapezoid is my little sample. It looks like my sample has a very similar mean to this population that didn't take vitamin A vegemin. So my vitamin A vegemin group, my no vitamin A vegemin population looks very similar. When I'm comparing the sample to this population, looks very similar. Similar means, right around 100 for both. Now again, we ask the question, so this time I'm not going to reject my null. I'm not going to reject my null. I don't think that there's any significant difference. And the question is, okay, so great, I made the decision, I didn't reject my null, I made a very good decision, it looks like. Am I right or wrong? And again, I answer, you don't know. Because maybe your population looks like this. In which case, you made a perfect decision. Good job. Your population and your sample are all nice and lined up. You did a great job. You made a perfect decision. You should not have rejected the null. Or maybe, I'm skipping ahead again. Same setup as what I just showed you, but maybe the population actually looks like this. You wouldn't know. You don't have access to the whole population. That's the point. Remember from the beginning, we're getting samples because we can't access the whole population. So maybe, even though your sample looks like this, your population looks like this. So maybe you didn't reject the null, but if we look over here, if we had had access to the whole population, we probably should have. Because look, again, we're in that same situation as before, where we're well beyond 2 standard deviations away from the no vitamin A vegemin mean. Okay. So now we can summarize. When you're right, it means that either you believe there is a difference and there really is a difference, or you believe that there's no difference and there really is no difference. When you are wrong, you believe that there's a difference when there's no difference. You reject the null and you should not have. That occurs with probability alpha. Or you believe that there is no difference when there actually is one. When there actually is one. So again, this first one, the C, occurs with probability alpha. It's what we like to call type 1 error, and this one is what we like to call type 2 error. And we'll talk more about those kind of errors in just a moment. Now you can make very reasonable decisions and still get it wrong. And that's part of the big point I'm trying to make here. Because we don't know what the population looks like. We only know what our sample looks like. Okay. So now I will explain this in a slightly different way. Okay, so let's take a look at this correct and incorrect decisions table. All right. So on the top, we have the true state of the world, the real situation, the thing that's really not known in practice. And in the true state of the world, either the null hypothesis is not true and there is an effect, or the null hypothesis is true and there's no effect. Now, we really can only control the decision we make. We can either reject the null or not reject the null. That's really the only thing we can decide on. So let's take the situation where the null hypothesis is not true and an effect exists. Well, if the null hypothesis is not true and we reject the null, we've made a correct decision. That's great. That's called power. That's represented by 1 minus beta. And this is just like situation A in the situations I was showing you before. If, however, the null hypothesis is not true and we do not reject the null, we make a type 2 error, a 1 minus power error, or beta, and that's a false negative. So in other words, there really was an effect, but we failed to find it. We failed to see it. Now, on the right-hand side, we're going to say the null hypothesis is true. Well, if the null hypothesis is true, if there's no effect and we don't reject the null, then we've made a correct decision. This happens 1 minus alpha. 1 minus alpha % of the time. And if you remember, we choose alpha. We typically choose alpha to not be any greater than 5%. So we hope that we make correct decisions at least 95% of the time when it comes to a null hypothesis being true. Now, if that null hypothesis is true and we reject the null, then we've made a type 1 error, an alpha, a false positive. This error in the upper right-hand corner here, that type 1 error, that alpha, well, that's what we try to avoid the most. We really, in the behavioral sciences, don't like a false positive error. We don't like to reject the null when the null hypothesis is true. When there is no effect, we really don't want to say there is one. That's the error we most like to avoid. Now, we don't like making type 2 errors much either. However, we're willing to tolerate them a little bit more in the field of behavioral sciences. So, for example, the type 1 error might be something like saying that this new medication that we just found that is supposed to treat major depressive disorder is far superior and works great. And so we make the conclusion that people should start using it, but it's a type 1 error. It actually wasn't more effective. This is what we don't want to make. That type 1 error, that's the one we don't want to make. There was no effect and we found one. Type 2 error, well, maybe the medication was really super awesome, even better than what we have today, but we didn't find that effect there. That's okay. People are likely to do follow-up studies in that case, and we'll eventually figure out that this was just a type 2 error, and it really was effective. See, we try to be very cautious and conservative. So we try not to make type 2 errors, but we really try not to make type 1 errors. Type 1 errors we tolerate only typically 5% or less of the time. Type 2 errors, we typically try and get our power around 80% is a gold standard. So our type 2 error, what does that leave? It leaves around 20%. Much more tolerant of this error than the type 1 error. I also want to point out that you can see, as I've been talking, that beta and 1 minus beta equals 1 or 100%. And alpha plus 1 minus alpha equals 1 or 100%. All right, these two have to add up, and these two have to add up to be the complete universe of options, because either in the real world, that's unknown in practice, the null hypothesis is not true, or the null hypothesis is true. We're either living in this land on the left or this land on the right. Okay. Let's do this one more way. Okay. So I'm not going to change much. I'm just going to add in these little red words here. Now, let's pretend for a moment that you are a jury. You are a member of a jury, and you have to reach a decision about this individual who's come to court as to whether you're going to convict them or not convict them. Now, the person is truly either guilty or truly innocent. There is some truth out there. You will probably never know for sure which side that it is. You're not going to know for sure whether that person is guilty or that person is innocent. All you can do is make the decision to convict or not convict. If they're guilty and you convict them, you've made a correct decision. Power. If they're guilty and you do not convict them, false negative, they got away. Type 2 error. They got away from you. If they're innocent and you do not convict them, great, you made a correct decision. If you're innocent, if the person is innocent and you convict them, that's a false positive error. That's a type 1 error that happens alpha % of the time. That's the one we're trying to avoid. We do not want to convict the innocent. So maybe that's a more helpful way to remember this. You do not want to convict the innocent. Okay. So think about all of that. Stay safe, be well, and I will talk to you next time.